Assalamu alaikum warahmatullahi wabarakatuh. We are going to start with the new lecture 5. We're going to discuss equation of the line and equation of the plane. First we'll discuss equation of the line, and I give you some initial ideas, and then we come back to that one. For example, we have the point here. This point in 2 dimensions, we say there are infinite number of lines can pass through this point. This line 1, this is line 2, this is line 3, line 4. So there are many lines passing through one point. But we say, if we have only 2 points, you have get 2 points. We say there is only one line which can pass through these 2 points. So there's only one line which is passing through these 2 points. This was point 1 and this point 2. There's only one line. So you can fix the line when we are having 2 points, there's only one line. But again, we are having one more idea, that if we are having a vector, we say we have the vector and we want to find the line passing through the point and parallel to this vector v, then there is only one line. Then again the line is fixed. When we fix the vector, the line is fixed. So to write the equation of the line, we need 2 things. We need a point and we need a vector. Or we say we need 2 points. When these 2 things we are having, we can find the equation of the line. I take the 3 dimensions. With this my z-axis, and this my y-axis, this my z-axis, and this my x-axis. And here is my origin. I'm having here 2 points in this this space, and there is a line passing these 2 points. This point is P1, and this point is P2. This here is x1, x2, y2. I will say here, we take this one as x1, y1, and z1. And this point x is any point. This one is my x, y, and z. So we are having here a vector given, there's a position vector, we can say. This vector is vector v. This line is parallel to this vector. So we can have here 2 vectors. We can take the vector. So here, coming back to this, and I can say we're having 2 vectors, a and b. Vector a is having the components, say this vector a is having components a1, a2, and a3. And b is a vector which is having the components b1, b2, b3. We say vector a is parallel to vector b. So as we are discussing the vectors, there is 2 vectors that are parallel, then we say b is equal to some scalar time t, a some scalar time t is any scalar. So then we say these 2 vectors are parallel. There is another way we are doing here. We say we can take here this definition a1 over b1 and place here is a1 over b1 is equal to a2 over b2 is equal to a3 or b3. They are equal, and say this is equal to t. The ratio is equal. We can take b1 over a1, b2 over a2, b3 over b3, and we say they are equal. Then we say they are 2. This is the case when they are parallel. Then these 2 are correct. This is number 1, and this here is number 2. My xyz plane, and in this xyz space, 3 dimensions, we take here point P1. This is coordinate is x, y, z. Point P1 is here x1, y1, z. This is the fixed point. And this any point on the line, we say point P, x, y, and z, any point on the line. So we can find this vector P1P. P1P is a vector is equal to x minus x1, y minus y1, and z minus z1. This is my vector. So given a vector v, the vector v is having this point is ABC, and we are having here this position vector v. We can take this vector as a, b, and c. We say these 2 vectors are parallel. When 2 vectors are parallel, then we are having here the definition that b is equal to t times a, or we can say the ratio of the vectors, the component of vectors is equal. We take this one, that this means this one P1P is equal to t times vector v. So we use this definition. We write the vector here. This is my x minus x1, y minus y1, z minus z1, is equal to t times v. My v is a, b, and c. Now here I can say that these two vectors are equal when their corresponding entries are equal. We can write this one as at, bt, and ct. We can write multiply by t. So we can say here, we get here x minus x1 is equal to at, y minus y1 is equal to bt, and z minus z1 is equal to ct. Or we can write it here, taking x1, y1 to the right hand side. We get here x is equal to x1 plus at, y is equal to y1 plus bt, and z equal to z1 plus ct, where t is any real number. This equation we say is equation of the plane. Sorry, is equation of a line. Is equation of line in 3 dimensions. A vector form of the equation. We can say here, because the vectors, so we say vector form of the equation. Now here we can say we need 2 things. Number 1, we need the point. For example, I have the point here 2, 3, and 5. And number 2, we need a vector parallel to the line. Vector parallel, we say the vector v is having the values, we're having here this vector v is having components 2, to change it here, going 4, 6, and 9. So now we want to write the equation of the line. We just substitute the point here and the vector components here. So I'll get here my x is equal to x1 plus a1t. x1 is 2, a is 4. So we get 2 plus 4t. And my y is equal to y1 plus bt. So my y1 is 3, my b is 6. So is 3 plus 6t. And what's my z? My z is equal to z1 plus c. z1 is 5, c is 9. So if 5, we get here plus 9t, where t is any real number, is equation of line passing through the point, P, and the components point P are 2, 3, and 5, and parallel to the vector, we say the vector v, and components vector v are 4, 6, and 9. So again, you give me a point and you give me a vector, I can give you the equation of the line. So we're having different way that how we can find the point, given the point, and how we can find the vector. Once we get the vector and the point, we can write the equation of the line. Just making a quick revision of the things we have done. We want to find the equation of the line in 3 dimensions with xyz plane and xyz space, and we are having the points p1 fixed in the space is x1, y1, z1. We take any point p on the line, and we see that when you have 2 points, we have the equation of the line. Then we are having vector v. We say these two are parallel. So we can write, they are parallel. We write the vector p1p is x minus x1, y minus y1, z minus z1. A vector v is the components are, because the position vector, so a, b, c. So they are parallel. This means that p1p is equal to some scalar time v. So it's p1p scalar time t multiple scalar at1, bt, pt, and ct. And then we take 2 vectors are equal and the corresponding entries are equal. So x minus x1 is equal to at, y minus 1 is equal to bt, z minus 1 is equal to ct. Take x1, y1, z1 to other side. We get the value of x, y, and z is equation of the line. You give me the value of t, I can give you the point on the line. For each value of t, we have a point on the line. For example, when we take t equal to 0, then we get this point, x1, y1, z1. We take t equal to 1, t equal to 2, t equal to 3, t equal to minus 1. We get infinite number of points on the line. So this is the idea. And then we're having here the example. We say we're given a point p with the components is 2, 3, and 5. And we have the vector, the components are 4, 6, and 9. The values of the point is 2, 6, and 5. So this is my x1, y1, z1. This is my a, b, and c. So x is equal to x1 plus a1t, y equal to y1 plus b2, bt, z equal to z1 plus ct, and t is an real number. This is the equation of the line passing through this point and parallel to this vector.